Hi everyone, I'm Julia Austin, and welcome to VMware. What a great group of people we have here. And thanks again for being patient with the logistics. We say the first test to coming to VMware is, can you traverse around our campus? And it can be challenging. Did everyone who had a long ride get champagne? Because they should have it if they didn't. So anyway, so welcome. We're happy to have you all here, and we're excited to host this event. So I'm in the way here. This is really weird logistics. I feel like I'm between you guys and a fence. So how you guys doing? So I'm going to do a quick couple of slides and give you a sense of who I am, what we do here at VMware, some of my thoughts about women in technology and some of the things that we do and why it's important for us all to get together in events like this, and then hand off to some of my favorite girl geeks who will talk more about the things that they're doing at VMware. And I think we're going to do Q&A at the end.
We'll have people stationed so you can ask the presenters questions.
Okay, perfect. Okay, so, and Karen's going to navigate for me because we are clickerless, so we're winging it here. So I talked about the agenda a little bit. You're going to hear a couple of really cool tech talks about some fun new projects that we're doing. And let's go to the next slide. And let me just tell you a little bit about who I am. I have kind of a unique background, and how I got into technology is kind of funky, but I have an art background. Actually, I did a lot of artwork when I was in undergrad, but when I was in undergrad, just to date myself a little bit, I was doing programming for graphics. I did graphics design, but back then it was all coding. So I was doing a lot of coding back then, and computer-aided design work, and decided I was actually really a geek at heart. My dad's an engineer and really got me started when I was 8 programming. That's a whole other story, but it was in my heart. I knew something I wanted to do. So I went on to do some variety of things in IT and technology and healthcare and consulting. Went on to the internet. Everything was going on with the internet that was exciting to me. So I was at Akamai Technologies, pre-IPO in the early days, all the way through the bubble and the burst. It was really a fun ride. Also another great talk I could give. And then I traded that bubble for another bubble, which was my kids. I have 3 daughters, and after the third one put me right over the top for a while, so I decided to take some time off and be home with my kiddo, all 3 of them. And then VMware called me 7.5 years ago and said, hey, we're in Palo Alto, we'd really love to be other places. So they actually asked me to come open their office for them in Cambridge, Massachusetts. So I actually am from the East Coast, and I started the research lab there. We have close to 300 people there now, and we also now have R&D shops all over the world, which is pretty amazing. When I joined VMware, we were 850 people, and that was 7.5 years ago, and we're now close to 14,000. So it's been a pretty amazing ride for us, and a really interesting, fun ride for me. Next slide. So what do I do at VMware? I actually drive innovation at VMware. I think I have a pretty fun and interesting job. Basically making sure VMware stays ahead, empowering people to think about their ideas, how to move them forward, how to fund things that might not normally get funded, but also how to not fund things that don't make sense. Across the company, mostly R&D, but I also work with teams across the company who have interesting ideas, either for products, revenue opportunities, or just to work smarter as a company. So we foster lots of programs. Some of them are just fun events that we run annually. Some of them are hackathon type things. Some are working within teams to figure out how to get an idea from just an idea forward. We run a great event once a year, which is, I can also just tell you, it's just a great, like a big science fair. It's really fun. We also do academic collaboration. So we partner with top tier universities all over the world to develop new solutions to things. Important thing for us there is not just writing checks to universities, but really doing collaborative work and research with academics, with students. We have great stories of students who've done collaborative work with us, who've come on to be employees at VMware, doing their thesis projects with us, etc. So it's another big part of what my group does. We have a VC model also internally, which is pretty cool, where people can pitch a new startup idea, and if we like it, we fund it inside of VMware. So I have a team of folks who do that, which is pretty neat. And the big thing is making sure that everybody's empowered to innovate at VMware. So again, don't keep your ideas silent. It's a theme also that I've been doing a lot of research around women, especially. We sometimes have a great idea, we're not sure how to vocalize it maybe as strongly as men do, and it's the reality of who we are. So we try to look at women in technology and how they do it, but also broader scale the whole company, and how do we make sure there are avenues. We have internal social websites, the event I mentioned before, lots of ways to make sure ideas come forward and keep things moving as a company. And we have a great history of firsts as a company, lots of things we've done that have been novel in our industry that started with just someone having a cool idea and making sure it happened. It's within our culture at VMware. Next slide. So girl geeks, I love this slide. It goes back to what I said before, is girls are sort of different than boys, right? I mean, there's I was saying to someone earlier today that the whole Mars-Venus thing, and I don't know how many of you guys have read that book or studied it. Yeah, it's a few of you. We're different, right? Not just because we can actually have babies and they can't, but we're different. We communicate differently. We think differently. We approach problems differently, and so this whole question of why are men different than women, how do we treat women differently, there's a camp of women who say, I don't want to be thought of or treated differently, just treat me like everybody else, but the reality is we're not the same, and I have really strong convictions about that. So it's important with events like this and other things that you do to connect with each other and figure out how to encourage each other to speak out about what your ideas are, what your interests are, to look for forward advancement or other things you're doing. It's just the reality is that we're different. And if we don't focus on those differences and make sure that we're here in the technology space, we'll lose it, right? We won't get the balance we're trying to achieve. I mean, everyone knows the statistics are already there that there aren't as many women in science and technology as there are as men. We certainly are very capable of being those people. We just need to encourage each other to get there to achieve balance. So things I think the value that women bring to an organization beyond just being really smart and amazing, because we are, is we're good mentors. We're natural nurturers. It's part of just who we are. We're wired that way to care for and grow and really encourage people to move forward. Next click. We're amazing multitaskers. How many people feel like they're multitasking every day in this room? Like to the nines, right? One of my favorite stories I was sharing with someone earlier tonight is, just to give you a sense, I have 3 daughters. This was me last night on a plane flying here from Boston. I was on the plane, 30,000 feet. I was Skyping I had 2 Skype threads going, one with a daughter who's at boarding school, one with my other 2 daughters who were at home, helping with homework, helping with some personal issues, advice on boys, and where is that belt that I need to wear tomorrow in the closet? And that's my life, and at the same time I was working on these slides. And I was at 30,000 feet. I was like, damn, I'm really good, but I was exhausted when I got in last night. But anyhow, the point is we're really good at this stuff. We're wired that way too. And I heard a great speaker once who actually said the science says the lobe in the back of our brain that's responsible for multitasking is actually bigger in women than in men, and that's why we're so good at this stuff. Anyhow, next slide. And if we weren't here in organizations, that's what the organizations would all look like, right? I mean, a little diversity is important, right? Okay, next slide. So another thing that I care deeply about is manager versus individual contributors. And I think as women, because we're good nurturers and multitaskers, we tend to also move more towards project management and leadership type positions. Part of it's by nature, but also the research points out that we are kind of pushed that way too. So I'm just curious, in this group, how many of you are managers, project managers? It's a lot of you. And scientists, computer scientists, programmers. That's not a bad balance here, which is good. So something I think about a lot is looking at young girls and trying to encourage them to stay the course if they want to be the individual contributor. Nothing wrong with being a leader. I love being a manager. I love being a leader and a project manager. But I think there's a lot of girls that sometimes feel like they're not going to move forward or that their skills aren't really being tapped. I see a few nods in the audience about that. So I want to share with you some of the things that we do at VMware and how we think about that. Next slide. So some of the things that we do internally, but also I think this can apply anywhere, is social network, like being here, right? Making connections and keeping your network, and constantly encouraging women to don't lose sight. If you meet somebody interesting, that could be a great connection for you, but especially women to women. We should be helping each other out. I spend a lot of my time connecting people to each other. You should meet this person because they could help you later on or with your project or whatever. And I think we have to take responsibility to do that. I call it early intervention or role models, but look for those opportunities where you see someone who needs a mentor, right? They're really smart, but they're quiet or they're not sure who to talk with. How are you going to help them get connected to the right people or devise mentoring programs at your companies, even if it's informal? We do that sometimes at VMware. We have our formal programs, but we also find ways to do these informal, like let's just have this person look out for that person so that they really can continue to move forward. Opportunities to lead technical projects. This is an area I think, again, we struggle with sometimes. Is, we want to be a contributor and part of the program, but can we step up and actually be the technical leader? It's, again, a real statistic on we just don't do that naturally. We don't see ourselves as innovators and leaders when it comes to the technical work. So looking for opportunities to lead, even if it's a small project, or again, when you're looking at a group of people and you're thinking about who's going to lead that project, really, I hate to say bias it towards the women, but if there's an equally qualified woman and you can give her an opportunity she hasn't had before, try to do that. Mentor and evangelize the experts. Again, I do that a lot here at VMware when I find women who I think would be great spokespeople for something, is to try to give them an opportunity to shine. And it doesn't have to just be internally, it can be externally. Continuous learning, training, education, get them out in the field. This is, again, most of this can apply to anybody, not just to women, but I think we have to just look for opportunities to do this. I mentioned innovation. We just had a great session here. I talked about the big event we do, the big science fair. We had a session at VMware specifically for the women to just talk and brainstorm about their ideas and how could they make sure they got a spot at this event next year. It's a coveted thing to do, but just to have more diversity and make sure we have some good balance at the event. And then the last part is to just be heard. Don't be afraid to speak up. Say what's on your mind. If you think an idea is a bad idea, suggest your good idea. But encourage other people to be heard. Don't always be their spokesperson. So at the same time that you're looking for opportunities for people to speak up, don't be the one speaking for them. Make sure that they're being heard, and you all should feel like you're being heard. I heard a number of people in the group just before this. I love just hearing how they were talking to people and introducing themselves, not just because we had bingo and really cool prizes, right, Karen? We have cool prizes, yeah. But because they really wanted to meet each other, and that's great, and you want to be heard. But when we network, I think we're going to have time to network afterwards too. Be heard about what you're doing. Talk about what projects you're working on and what's interesting to you, not just where do you work, but look at this as an opportunity to do some thought leadership as well. So the last piece is just balance and keeping your priorities in check. This is I hate using the term motherhood and apple pie, but it kind of is. This doesn't matter if you have kids or not. This doesn't matter, if you're balancing a family or not. This is just about you as individuals. For me, it's what keeps me grounded, is making sure my priorities are in check, making sure that whether I'm an individual contributor or a leader, that I don't make myself do everything, that I realize there's some things other people can do. They might not do it the way I do it, but it'll get done, and it will get done well. It's a growing and learning opportunity for other people. But not to knock yourselves out and trying to prove everything is still important, I think. And then, again, we struggle with that. I see as women sometimes, especially if we're balancing other things outside of work, how do we continue to prove to everybody we're killing ourselves? We just do that. But just keep it in check. And I say have a life, like really have a life. Like go do things. I'm a self-proclaimed spa addict. Anyone here who knows me at VMware knows that I go to spas a lot. If I travel for work, I find a spa. I can't help it. It's what I do. But it keeps me whole, and that's a good thing. And I think there's nothing wrong with that. Taking care of yourself is really important. And finding your outlet, whatever it is, if you run marathons or paint or whatever you do, just make sure that you do that. And I think it makes you better. I mean, what I find is whether you're male or female, when you keep yourself doing things beyond just work and day-to-day life, you just overall, you're going to do better work in the long run. So that's my advice. Anyway, so I think that's it, right? That's my last slide? Yeah. So happy to talk to people after this. Really excited about our next speaker. Melina and I have done quite a few speaking engagements together. She's awesome. And enjoy the rest of the talks.
Hello, I'm Melina McClarty, as Julia introduced. I work on our user experience design team. I spend a lot of time thinking about the design of our user interfaces, specifically for vSphere and vCloud Director. Go to the next one, please. This means thinking about how our users spend their time here, in data centers, managing their virtual environments. We think a lot about how to make these experiences efficient, elegant, simple, and sometimes even fun. But for this project, I started thinking about somewhere where we probably all spend our time. And for me, that's in a cubicle and also in a conference room. And I started looking at this experience where we spend our time during our day doing meetings, being productive, and getting work done. But there was a lot of problems around booking and finding conference rooms and meeting rooms and managing your calendar. And I wanted to simplify this experience. So I went ahead and employed my design process, starting with the user research phase. I began this phase talking to people who manage calendars, which for many of us at VMware, it's everywhere, whether it's on my design team, development, project management. I also ran a few surveys on our internal social network called Socialcast to find out how other people are managing their calendars and understanding the problems that they're facing. A cool thing that I found working with this is I started to think about who has this problem the worst? If anyone was struggling with calendars, who would it be? And these are people who work with a lot of calendars, administrative assistants. These people are not only managing their own calendars, but they're managing the calendar of one or more people. I started to talk to them to understand what problems they were facing. Then, of course, moved to the design process. And in this phase, I looked at the use cases and areas where people were having troubles, and I ended up focusing on one area, one specific use case, the impromptu meeting. You've probably been there yourself when you're sitting at your desk and someone comes up and wants to chat. Well, what happens? You have to get up, walk around, find an available conference room. And at VMware, that can be kind of a trick, but at a lot of companies, it's the same problem. Conference rooms are booked. Or you just go ahead and have that meeting in your cubicle and talk loudly and disrupt the people around you. This is a big productivity sink. So I started to think about, just like we do for the data center, how can I make this experience simple, elegant, and even fun? Well, imagine when that person shows up at your desk, you pull out your smartphone. Go ahead and click through this. You pull out your smartphone. In one click, you book, the system goes out, takes your current location, and books the nearest available conference room to your location. And if you're new to the building, in one click, you could toggle over to some walking directions and see a map to get right to your conference right away, being productive. And as a fun feature, you can even hold up your phone, use the rear-facing camera on the phone, and see walking directions in augmented reality. Now you're also having fun finding your meeting, and most importantly, you're not dealing with this problem that we had before. This is the part of the design process where I started to get feedback from a lot of people and found that this was solving their problem. But I needed help. I didn't know a lot about location awareness algorithms. As a designer, it wasn't a space that I had done a lot of research, so I started looking for help. I reached out to colleagues. I started talking about this solution space to anyone who would hear me out. And I actually found somebody who was working on a location algorithm for a different problem. And it wasn't until we came together that we were able to solve my problem and their problem actually in an approved way. So to build this system, we needed a few inputs. The first is obviously campus maps. This was easy. Every major building already has these maps. Maybe some maps would have helped you find your way to this event tonight. And conference rooms availability. Of course, our calendaring system already has this. We know which conference rooms are available and at what times. And user preferences. An example of user preferences is something like how far you're willing to walk for an impromptu meeting. A manager or someone in HR might be willing to walk a little further because they deal with sensitive topics, where someone else might opt to go for the meeting in their cubicle if nothing nearby is available. And the last one, of course, the user's current location. This is where the problem got tricky, but we actually already have the data available. You might be thinking, use GPS. I use GPS on my phone to navigate the streets of Palo Alto. Done. Unfortunately, GPS doesn't work well indoors, so we needed something different. If you're familiar with the space, you might even think, well, you could use Wi-Fi inside the building and the Wi-Fi on your phone or mobile device. And it is actually really good at creating an initial approximation for where you're located. An additional benefit that Wi-Fi offers is it leverages existing hardware. These are Wi-Fi routers and access points already available in every major building. The solution doesn't require that we set up additional hardware or people carry a different device so we know where they are. It's leveraging things that already exist. But Wi-Fi data alone, that initial approximation isn't accurate enough for walking directions. And really the walking directions was that fun feature that really completed the solution. So we actually went out and built a machine learning algorithm that could not only predict your location, but it got more and more accurate over time. And we trained the system using 2 data points. We can look at your Zimbra calendar, and it says you're supposed to be in meeting room C5. So we know where you're supposed to be. We can look at your Wi-Fi prediction and guess where we think you are. And if those two are close, we can use that data point to train the system. If they're far away, we'll assume you skipped the meeting and throw that data away. We can do the same thing with your desk location. And over time, this creates an algorithm that is very accurate and gets better and better. Now, we built a small prototype in one of our buildings here to see how this works. And we actually got accuracy within 2.5 feet of your location. And 2.5 feet is plenty accurate enough for walking directions. And it's actually an 87% improvement over Wi-Fi data alone. The really cool part about this problem is that it's just the beginning. Now that we have location awareness in calendaring, we can solve a whole set of other problems that people were experiencing with their calendars. You can book meeting rooms that consider travel time for all the attendees, so you're not bopping across the campus. You can share your current location with coworkers, so you can more easily find them for quick face-to-face chats. Or you could even think of this location awareness technology and how it can apply back to our data centers, because managing people in conference room isn't too much difference than managing resources and workloads. And that's why this technology is really exciting. If you're interested in location awareness, calendaring, or design, please come see me after. Thank you.
So hi everyone, I'm Natasha. A little background on myself. I'm an engineer here in VMware's networking unit. I'm also a Stanford alum. I finished my undergrad in 2007, at which point I joined Nicira as one of the first few engineers. And so it was there that we started work on network virtualization. And then in August, VMware actually acquired us. So now I'm continuing that work on here, working on the same product, and that's what I'm going to focus on today. So first off, what is network virtualization? And the technical definition is that it's the idea of providing a user with a fully functional network abstraction, but one that's completely decoupled from their actual infrastructure. So what does that mean? That means that a network that the user sees and manipulates, sees their host connected to, and configures policy across, doesn't need to match what they have at their infrastructure layer. And this is what virtualization is in general. It's the idea of your hardware not restricting the views and abstractions that you build on top of it. So for a more concrete example, right, I have these 3 green hosts, and just because I want them to be on their own separate, completely independent network, doesn't mean that I have to make sure in hardware, like I have to go out and build a separate network for just these 3 hosts. Furthermore, just because for simplicity's sake, I may want these 3 hosts to be connected to the same network device, so that I'm only worrying about policy on this one device, doesn't mean that in reality, I have to make sure a single box exists that all 3 hosts are plugged into. So given that, you may ask, okay, that's nice, why do I care? And you care for the same reason that virtualization has been useful in all other realms. Because now all of your hardware just becomes like a general pool of resources that you allocate from on demand, and more usefully, you can share it across completely independent and unrelated users. You can safely and securely share this infrastructure, which allows for the potential for a lot of cost savings. So the next definition that I wanted to go into before going into our product is software-defined networking, or SDN. And SDN is exactly what it sounds like. It's any type of networking logic that's been programmed in software. And it's the approach that we've used to implement network virtualization. And one of the huge advantages of SDN is that now when you want a new feature, a new upgrade, you're no longer going out there and buying a new hardware device. Instead, you're more just pushing a software patch or a software upgrade, which again speeds up your development type a lot. Oh, higher? Oh, sorry. So the product I work on is called the Network Virtualization Platform, or NVP. And what NVP does is allow a user to create multiple virtual networks on top of a single shared data center infrastructure. The idea is that these virtual networks should behave identically to if that network existed in hardware. So users should not see a difference at all. But again, all of these hosts are connected to the same network. So to be more concrete about that, I might want 10 hosts to be on their own individual network, and I want these other 10 hosts to be on a completely separate, isolated network. And just because I want that doesn't mean that all 20 of these hosts need to be on different networks. They can all be plugged into the same infrastructure, and even running on the same hypervisor, for example, in the virtualization case. So the example I'm going to use to motivate, why network virtual, our product in particular, is that of a hosting provider. And a hosting provider is housing multiple customer environments in their data centers. And a hosting provider doesn't want to go out there, and lay out separate networks and physical machines for each of their customers. They want to host all of these customers on shared infrastructure and leverage the fact that they can do that. And so what NVP does is address the networking aspect of this. So if you think of a customer, right, they'll have a virtual machine or a VM that's running in the cloud. And every time they use this VM, it could be running on a different physical server, right? They have no idea where it is. And so what MVP does is make sure that any networking policy that's associated with that particular VM will follow it no matter where it shows up in the network. So like a straightforward example of this is a customer may say, I want these 3 VMs to be able to talk to each other no matter where they show up in the network. So MVP will make sure, no matter where these VMs show up, they can communicate with each other and only with each other. So the way we've implemented MVP is as a small cluster of nodes. This is usually like 3 to 5, so very small. They could potentially manage a very large network. And what these nodes are doing are dynamically programming the network to fulfill those virtual networks I showed on the first slide. So for each connected host, the controller is determining, okay, which virtual network is this host a part of? And then make sure that any traffic being sent or received by that host stays within the virtual network. Now, MVP doesn't do this by talking to the hosts. So like the hosts have no idea that MVP is running, that they're on a shared network to them. They're on their own separate virtual network. But what MVP is doing is actually talking to their first hop, their first network hop. And so this is the device that the host traffic first goes through. And it's in this way that MVP is leveraging SDN. Because these first hop devices are actually very simple. They don't have any idea what virtual networks exist, what other tenants there are. These first hop switches are very simple. And it's the controller that's housing all of the logic. So the controller is dynamically telling the switch, okay, this is what you should do when you receive traffic. And so that's how MVP is leveraging SDN. And there's 3 things I wanted to highlight about this model and how it's useful. So the first, I feel like I'm repeating this a lot, but it's just a really big deal, is that the networks that a user defines are completely independent from what exists in hardware. So, a user can define whatever will make their life easiest. It could be a single switch, it could be a switch and a router, whatever it is, and they don't need to worry about how that maps onto the actual network. They could also be using the same IP addresses as somebody else. They could really just do whatever they want. And MVP will take care of making sure that that type of behavior is seen by the hosts. The second thing I wanted to mention is the fact that these controllers are automatically managing mobility. So, when you have VMs, right? Like I said before, VMs can migrate between different servers. And to MVP, this just looks like a new location in the network. And when MVP sees a VM or a new host show up, be like, hey, I need to configure this first hop device to manage that host. And then the last point is upgradability. So this is kind of on 2 levels. First, if you take the actual user who's defined the virtual network, if they want to change what their virtual network looks like, so they've decided, oh, I actually want 2 routers, or I actually want this quality of service policy. They just need to tell the control cluster, hey, change my network to be like this. And MVP will take care of actually configuring it in the network, but the user isn't worried about, oh, I need to configure this device, I need to go touch things in these different places. MVP is kind of taking care of all of that complexity. The other level of upgradability that MVP helps with is from the developer point of view. If we want to push out new features, because we want to give our customers oh, here's a new feature that we've developed. We're not going through and upgrading an entire network and touching different spots in the network, right? We're just touching this one control cluster, which again is said is just 3 to 5. It's depending on, eventually, our hope is that we'll scale immensely, and you'll need maybe 10 controllers or 11. But for now, it's just 3. So when we want to upgrade, we're really just talking to these 3 nodes, even though the network could be thousands of hosts. So I wanted to end on, I've talked a lot about these benefits and what's great about network virtualization and what we're doing. But I really wanted to talk about the challenges that we work on, because that's what's made this problem interesting for me, and it's stuff that we continue to work on today. And the thing to kind of keep in mind is that network virtualization doesn't remove any of the complexity of managing a network, right? That complexity still exists. The hope is just that it hides it from the user. The user shouldn't have to deal with this we should be able to solve it once, and that should be the end of it. And so the first class of challenges I wanted to talk about were scale issues. So, MVP should be managing, at minimum, networks of like hundreds of thousands of hosts. And when you have networks of that scale, things like latency really become an issue because you have to make sure that you're responsive. And so the first question we have to answer is, okay, if a user changes their virtual network, how long does it take before MVP will actually push that down to the physical infrastructure? Right? I mean, we can't say, oh yeah, you want to change your network? Okay, we'll get back to you in a day. That's way too long. We should be getting back to you within like seconds. So the next thing is, how long do we take to configure a new location? So if a new VM shows up or a new host shows up, how long before that VM or that host sees the network policy that's been configured in its virtual network? Again, this time should be like minuscule. You shouldn't even notice it. As soon as the VM comes up, it's done. Then the last scale one. So I talked a lot about how all of the logic is hosted in this control cluster, which means that those nodes are immensely important. So if one of them goes down or there's some kind of failure, how long do we take before we're available again? We don't want the network to be down in the meantime, and we also want to be able to service new requests as soon as possible. And then the other class of challenges I wanted to talk about were, again, upgrade. Again, I spent like the last 3 slides going over how easy it is to upgrade, but in reality, there's still a lot of issues. And so the first point is, again, we can't afford any outages. Just because I want to update this control cluster doesn't mean that like customer networks can be down in the meantime, right? That would be unacceptable. And so we have to make sure that there are no outages and that we'll respond to queries like as soon as possible. And the last one again is rollback support. So things go wrong all the time when you're upgrading. And the thing is, when you're managing a network, if you mess up, your entire network is down. And again, we can't afford to do that. So how do you make sure that if we're trying to upgrade the network, that in the worst case, there's still no like unrecoverable outage? And so these are kind of like the big issues we work on, and we've solved a lot of them. But as we try to support more and more hosts, like it just becomes harder and harder. And so these are things that I get to work on, and that's what's kept things interesting for so long. So I think that's all I had. If you have any questions, feel free to come by. I know I talked about a lot, so feel free to come by after, email me, and yeah, I think Xiaoyun is talking next, so thank you.
Hello, I'm Xiaoyun Zhu. I'm a software engineer in the Cloud Resource Management team of VMware. There's some echo? No, it's okay. So what I'm going to talk about today is some automated solutions for performance diagnosis for applications that are running in the cloud environment. So just to motivate the problem, if we imagine that there's someone like Alice who is a service provider that's providing infrastructure as a service to a lot of tenant customers for running their applications. And there's a Bob who is a tenant who has deployed a business critical application on this infrastructure. So, so this picture illustrates a multi-tiered application for serving web users. So by multi-tiered, I mean that this application actually consists of many distributed components. So web servers, application servers, clustering server, database server, and each of these components can be running in the virtual machine. And all of these VMs that are supporting a single application may be spread out in the virtualized infrastructure. So the user doesn't really have to care about specifically where they're running. So now let's imagine at some point the throughput of the application drops significantly. So that indicates a violation of the service level agreement. Obviously, as a customer, Bob will contact Alice and ask, what's happening? Why is my application behaving poorly? So as a service provider, Alice will have to answer some important questions. For example, where is the problem really occurring? For example, for distributed application with lots of different components and running in a possibly heterogeneous environment, you have to figure out, which VM, which application component, which particular host, which networking component might be related to the problem you're seeing, and exactly what happened that actually caused the problem to happen. And finally, what can I do about it, which is the remediation step. So all of these are important questions in order to resolve the problem. If we think that this is a very difficult problem, and let's imagine if we actually have even a larger scale environment with multiple data centers, possibly hundreds to thousands of tenant customers running many different applications in a unshared infrastructure, and multiple of them may be having performance problems at the same time. So for that reason, we will need performance diagnostic solution that can actually work at the cloud scale. So let's look at traditionally what people have been, what kind of approaches they've used for tackle these kind of problems. First, obviously, you can approach an expert. So these are people who have very deep knowledge in a specific domain or specific application, who have built up their mental models about how things should work. The disadvantages of this kind of approach is that obviously, the resolution time can have high variance, right? Maybe as fast as minutes or as long as weeks. And it's very hard to scale up because even when you have experts, a single person cannot possibly handle many problems at the same time. It's also hard to scale out because these kind of mental models are hard to codify and kind of diffuse to other people so that a lot of problems can be addressed at the same time. And another approach, probably more for non-experts, is to follow what we call cookbooks, or like performance best practices for administrators, for example. And VMware publishes multiple of these books that users really use a lot. And they typically provide standard set of steps for people to follow, what charts to look at, what resource to look at, and maybe what logs, what keywords to look for, which can be quite effective for certain problems. But it also has its own issues, which is that these kind of books can only give you solutions for problems that we're seeing before. And in a cloud environment where it's highly dynamic and variable, you're likely to see new behavior or new relationships that were not captured in these books. So what we're trying to propose is that there's so much data in the cloud these days. There is a really very rich telemetry of data that are being collected for both at the application level and at the system level. So how do we leverage all these data, right? So for example, at the infrastructure level, there's a lot of performance metrics that are constantly being collected and being exposed through APIs, both from within, could be within the virtual machines, or could be at the system level or at the hypervisor level that can be leveraged. And at the application level, there are also various tools that people can use to collect application performance metrics, including like transaction throughput or response times of the throughputs or requests, whether it's mean response time or maybe it's percentiles of response times. For example, VMware has this tool called Hyperic that users can deploy into the VMs that are running the critical applications in order to get the application level stats. So with access to these kind of data, we're likely to answer some of the important questions. For example, what are the infrastructure level metrics that are kind of mostly correlated and possibly affect the performance that you're actually seeing? And also, which one of the large number of system components is actually the bottleneck that's causing the performance degradation? So our proposal here is really go after a data-driven approach. There is a kind of a large class of mature statistical learning and data mining techniques out there that people have successfully applied to many other domains. So we should try to leverage them and use these approaches to hopefully help us quickly identify what are the focal points for the performance problems so that human can dive deeper into these problems. And the advantage, obviously, is that you make less assumptions about the specific application or system that are being used. It's much easier to automate because of the nature of this approach. And also it's more scalable because it'll be easier to codify these kind of techniques or algorithms so that you can deploy them for a large number of systems and applications. And this approach has its own challenges because you need to deal with a large amount of data, most likely in real time. So it really needs to be very efficient. It also has to have good enough accuracy and need to have good ways of dealing with false positives and false negatives, because both of these might be quite costly depending on the scenario. And needs to adapt because we know it's a dynamic environment where the applications can change, the infrastructure can change, the workload behavior can change. So adaptability is critical. And finally, because it's a statistical approach, it allows you to find correlations in your system, meaning that these metrics and these other set of metrics are related, but they don't necessarily lead to causality directly. So that requires a little more human involvement or other active probing kind of approach to get to real causes. So at VMware, as part of a research project, we built an automated performance diagnosis tool that focuses on problem localization. So the first step we do is that, given the large number of metrics, infrastructure level metrics that are being collected by the system, we run very simple correlation-based analysis to filter out, possibly 80% or even 90% of the metrics that are not correlated with the performance you're seeing at the moment. And in the next step, we use a smaller set of metrics that we identify to build a performance predictive model. So we have an iterative approach to allow us to pick an even smaller set of critical metrics that give you the best predictive performance. And with that model, that model allows you to capture the application behavior for a certain period of time, but because of the dynamic behavior that I described before, this model itself may need to adapt because, maybe for a certain period of time there's some kind of CPU contention in the system, it might go away. Then, later in the week, because other nature of the application, you might have disk I/O issues or you may have other issues. So we do have an online change point detection algorithm that allows us to identify when the current model is not capturing, when the previous model is not capturing the newly observed behavior at that time, our algorithm will adapt the model and try to discover new metrics that are more representative of the current behavior. So this one, as I mentioned, focuses on problem localization. So by presenting that more focused information to the administrators, we help with the root cause analysis process, but we're not yet fully automating that process yet. And the remediation at this stage will still be manual. So what I'm saying is that we haven't really completely eliminated human in the loop, but the hope is that by leveraging these kind of techniques, we at least help the human administrators to become more effective in their work. So this is a small case study we did where we run the application that I showed you before, which is a 4-tier distributed application running in 6 virtual machines. So we ran these 6 virtual machines on 4 ESX hosts. And on the first ESX host in these small boxes with a dashed line, we're also running a number of noisy neighbors. So problems you might run into in the virtualized environment where they might compete for certain resources with some other application. So in this particular case, these kind of neighboring VMs will be consuming certain amount of CPU such that it causes CPU contention on the first ESX host. And on the right-hand side, we're showing the performance numbers for the application. So the top graph, the blue line is the number of users we're emulating for the multi-tier application. The red line indicates the number of noisy neighbors you're running on that first host. And on the bottom graph, we show the measured mean response time of the application and the model predicted response time, which captured the trend reasonably well. And as we can see in this middle period where we do have these neighboring VMs running, that's a period of CPU contention that actually caused the response time to be much higher. So as part of our algorithm, it not only trained certain analytical models to capture that behavior and find the top related metric, it also, these vertical lines indicate where the model adapted to a new model to capture the new trend. And so here I'm just, as illustration, show some of the example models that were chosen by the system. And the key observation here is that, so we're only showing the contention period, then at least all of these models are indicating that the CPU resource on the first ESX box is most correlated with the performance you're seeing, which happens to be the resource bottleneck in this particular case. So just to summarize, I think what I've described here is that there's a lot of performance data available both at the infrastructure level and the application level. So we should really try to leverage the power of the statistical learning algorithms to filter irrelevant data, gain more insights into the critical information that allow us to solve some of the important tasks for managing these applications. And also self-adaptation is very important because we're dealing with a very dynamic environment here. So we also kind of, as future work, look at some other further directions for this work, including how do we further automate the root cause analysis process and also the performance remediation process using some other analytical techniques that can help the administrators even further. Thank you.